In section 2.3, we look at other types of displays, and there's two other types of displays that we're going to discuss, and that is a time series graph. And so I'm going to show you how to construct that within your homework, because you're actually going to use the online interface to construct one. And mainly this is just solely for the purpose to identify trends. And so this one is a temperature over a 9-hour period. We have the temperature on the y-axis, we have the time, the 9-hour period on the x-axis, and we can pretty much see more or less what we probably already know about temperature is that it steadily, I guess depending on the season, but steadily increases to a certain point, reaches its apex or its height, and then it starts to decrease after that. And so that's what the trend is we're recognizing here. Now in your homework, for section 2.3, there are two questions, and the first question is a time series plot. And so I want to kind of overview with you how you would do that, just in case anyone might have issues. I want to kind of show the interface for the homework. So here it shows some data about coffee consumption, and part one is just to plot the data, and it gives you down here line segments I want you to plot. So if I look at, I wonder if I can, no, I can't make this any smaller, so no, that's okay. So from 1995 to 1996, it went from 3.4 to 3.8. So if I click on the appropriate line segment, from 95 to 96, it was 3.4, so probably a little less than half, and then 3.8, not quite 4, so there. So we're just kind of estimating where it should go. And then from 96 to 97, 3.8 to 3.9. So click on the next segment, and then 3.8 to 3.9. And then from 97 to 98, from 3.9 to 4.0. So from 97 to 98, 3.9 to 4. And then 98 to 99, from 4 to 4.3. So 98 to 99, from 4 to 4.3. And then from 99 to 2000, so from 99 to 2000, 4.3 to 4.5. Yeah, 4.3 to 4.5. So 4.3 to 4.5. So let's see. So it has a reasonable tolerance in there, so you can get close to it. Now I may have not got close in certain spots, but the tolerance, it recognized I was around it, so it gave me a check mark. And then it's asking you to interpret that information. So over the years, is the coffee consumption per capita increasing, decreasing, or both? Well, it's increasing, right? It's only increasing from 95 to 2000. If there were one instance where it went down and went back up, then we would say both. But for this one, it's increasing. And that's it for that question. Now, for the second question, we look at a stem and leaf plot. So that's the other type of graphical display. And the stem and leaf plot just uses part of the data as a stem and the other part as a leaf. So we can look at, are there any groups, or are there any type of classes, or any clustering of some sort. This is a stem and leaf plot here, where the first value represents the stem, and the second value represents the leaf, or the trailing digits. Stem and leaf plots is very easy to determine the min and max. The minimum value would be 2. The maximum value would be 57. So if I put this 5 and the 7 together, that makes 57. It is easy to see clustering in the data. So if well, here we can see that there's far more data values here in the 30s, ranging from 31 up to 36. And it tends to increase, and then after 36, it decreases. We can also kind of see how the data values are distributed. So we can kind of look at this like a histogram. However, we have access to it shows the original data in the distribution as opposed to just the frequencies like in a histogram. And so I wanted to show you in the homework how you would construct it in the interface that we're using for our homework. So if I go back to Connect Math, and I go up to the top. So in your homework, it will already give you the stem, the first two digits. You just have to find the leaf. So it says construct a stem and leaf plot for the data. Do not separate the answers with a comma. If there are no leaves, enter an N. Every homework you have, you'll be able to download the data, and that's probably the easiest. If I didn't download it and I look at this 10 here, I would have to go through this distribution and look for any value that starts with a 1 and a 0, and that may be a little tedious. In the first row, I have 100, so that would be a 0. In the second row, I also have 100, that would be another 0. In the third row, I have none. In the fourth row, I have none. And I would keep doing that process. I got to 19. That's a very tedious process, and you may not want to do that for all of these data values. So instead, if I were to download the data, so here in the corner, it's going to download the data, and then it'll open up, and you will have to enable editing. And what I would suggest is drag it over to the side, release it, and then it would allow you to select another screen. So now you're working side by side. We really want to look at, well, first, I want to arrange the data in order from least to greatest. So I can easily do that in Excel. I may not want to write all this out by hand from least to greatest. That you can do it, but it's very tedious. So if I highlight the column and I click on data and I'm going to sort from A to Z, it's in order from least to greatest. And now I can easily see, well, here are those first two already found. Would start with the 1 and a 0, so I can get rid of those. And then anything that starts with a 1 and 1 or an 11, so it's two values. So 0, 0. So I can get rid of those now. And then next, anything that starts with a 1 and a 2. So there's 4 120s. And I can get rid of that. Anything that starts with a 1 and a 3, there are 5. So, and then any value that starts with 1 and a 4, there are all of these starts with 1 and a 4. So there's 4 140s and there's 3 145s. So 1, 2, 3, 4, 1, 2, 3. And then for 150, there's 3 of those. And then 160, there are 5 of those. They all end in 0. And then 170, there's 1. 180, there's 2. And 190, there's 1. And then we can check our answer. So it's correct. And so that's the gist of a stem and leaf plot. We have access to the original data. We can look at the distribution of the scores. It looks like more of the data kind of fall in the middle of the data set, whereas in the beginning and in the end, it sort of tapers off. So if we talked about the shape of the distribution, we could say it's roughly bell-shaped. If I were to draw a curve over this like we looked at with the histograms, but we don't really have to do that for this chapter. You just have to be able to construct those two and then move on.